This is a quick video covering how to graph a linear inequality. So I think I'm just going to go ahead and start with an example. Here are actually two examples. The first one's going to be in slope-intercept form, and I'm going to go ahead and graph the line. Just kind of remember that if you have these two symbols, the less than or the greater than, you're going to use a dashed line. And if you have a less than or equal to or greater than or equal to, you use a solid line. So in this case here, I have a less than symbol. So I'm going to go ahead and graph this equation, starting with my -2, that's my y-intercept. My y-intercept is -2, and my slope, which is my 4, is equal to 4 or 4 over 1. So let's start with that. I'm going to plot my -2 right here. And because my slope is 4 over 1, which is positive, I'm going to go up 4 over 1. 1, 2, 3, 4 over 1. Right there, I'm going to do probably another spot right here. 1, 2, 3, 4 over 1, which is just going to extend my line a little bit, make it more accurate. So down, 1, 2, 3, 4, back 1. And again, I'm going to use a dash line. So I'm doing this freehand because of the software, but hopefully you'll be using a ruler. And you also want to draw arrowheads at the end, indicating that even though it's an inequality, that line, which is a boundary line between the side that solves your inequality and the side that does not, that goes on for infinity. So now, let's talk about which side to shade, because you always have to shade linear inequalities. There's two ways to do this. If it's in slope-intercept form, you can use the general rule that if it's less than, you shade down. I almost said up, didn't I? And if it's greater than, you shade up. Okay? In this case, because it is less than, we'd be shading down. All right? And I'm just going to go ahead and just draw some lines in here to represent shading, which is perfectly fine. And another way you can do this is you can also use a test point. And I always like to use a test point 0, 0 right here to see if it works in my inequality. Well, what you do is you plug those values of your x and your y. Well, at the origin, my values are 0, 0, because that's what this is, 0, 0. And I decide if it would work. Well, I would have 0 is less than 4 times 0 minus 2. Well, that's 0 is less than -2. Well, that's not true. 0 is actually greater than -2. So that would tell me, even if I didn't know the general rule, that would tell me that I would be not shading the side that contains a 0, 0. I would be shading the other side. So either way I do it, I'm going to be shading this side. Now, just want to talk a second about why we use a dashed line instead of a solid line. You have to think about this line as being a boundary between all the points that solve your inequality and the side that doesn't. So every point over here is going to make my inequality a true statement no matter what I pick. And when I plug any one of those in, I get a true statement. Well, you have to also designate whether your boundary itself, this boundary line, makes your statement true or not. And because I don't have an or equal sign under here, I don't have that line under here, the points along my line don't make my inequality true. So by making it basically dashed, which is sort of like half and half line, half not line, I'm indicating it goes with this side over here, the non-solution side. If I could draw a line in white and it would show up, I would do it that way, but we can't draw a line in white. Usually we have white paper and we're drawing with pencils, and the solution area is being shaded dark. So by making it half and half, we're doing the best we can to indicate that it goes with this side over here. If it was part of the solution, I would make it solid to indicate it's part of the solution on the right. Let's talk about graphing number 3. X minus 4y is less than 12. It's not in slope-intercept form, so I have two choices. I can make a table and find the intercepts, and I notice that I've got a coefficient of 1 for the x and a -4 for the y, and both of those are factors of 12. So I think I'm going to go ahead and make a little miniature table to find the intercepts. And what I do is